Alright, we are looking at lesson 10.4, areas of regular polygons and composite figures. So you should be looking at, or starting off by skimming for examples in lesson 10.4. Predict 2 things you think you will learn about in areas of regular polygons and composite figures. You can do that now or later. We'll look at some active vocabulary, some review that we've talked about before. We're talking about angle A, talking about a central angle. Maybe some of you might have thought that it could have been a right angle. I guess it could also be a right angle if you wanted it to be. Right angle seems fine as well. Doesn't really indicate that it's a right angle, but it looks close enough to a right angle for me to say, yeah, right angle. Central angle, though, that's the one we're focusing on. It comes out of the center, so it's not an inscribed angle. You guys remember inscribed means that its endpoint is on the end of the circle, or the edge of the circle here. That would be an inscribed angle. We're not talking about that, though. Central angle. Then the portion of the circle defined by endpoints is an arc. An arc. From B to C, that would be arc BC. Alright, then we've got a couple of new words here. We've got apothem. Apothem. It's a segment drawn from the center of a regular polygon and perpendicular to the side of a regular polygon. Apothem. Then radius of a regular polygon. That's a radius of a circle that is circumscribed about the regular polygon. Then we've got center of a regular polygon, the center of a circle in which the regular polygon is inscribed, and the central angle of a polygon. It has its vertex at the center of the polygon, and its sides pass through consecutive vertices of the polygon. So, again, we'll kind of look at some of these here whenever we look at this page, second page here. Okay, it'll kind of walk us through. We're going to identify some of those things that we just talked about. So the center would be V, this part right here, that's the center of that. So if we were to create a circle that went all the way around this, let's just see how it turns out. Okay, the center of the circle would also be the center of the polygon. Okay, that's how we found that center. If we're talking about a radius, we can say the radius QV or VQ and VR or RV are both radii. Okay, they go from one of the vertices all the way to the center, because again, if we had that circle going around this thing, it would be a radius from the edge to the center. Okay, so we go from the edge of the vertex of these angles here. So any vertex, that would give us the radii from Q to V. Okay. Then if we're naming a central angle, that would be the angle that comes out of, it says, and it defines it kind of weirdly. It's like a lot of words on that last page, but again, it goes to the center, and it's not talking about, so a central angle here we wouldn't be talking about QVS, okay, even though it goes from the center, but the central angle in a polygon, it has to go from one vertex to the other, so from Q to R, like that would be the angle right there, not Q to T, not going there. We're not doing that, no. We're going from Q to R. So that angle from QVR. So the next vertex over. So we could do QVU, that'd be fine. Or UVT, or TVS, or SVR. We could do any of those. Those would be central angles, but the others, if you skip one, so we couldn't go Q to T because that would not be a central angle. Okay, then name an apothem. And the apothem is at that perpendicular. You can kind of see the 90-degree angle that they represent right there. it's 90 degrees and it's directly in the middle. So it bisects this QR right here. It bisects it perpendicularly. So this would be 1/2, and this would be 1/2. So that is the definition of an apothem. So it goes at a 90-degree angle. It's a perpendicular bisector of this section right here, leading straight to the center. Okay, and then from there, we can just get into this a little bit where we're talking about finding the area of this figure. So if we've got this, the area is 1/2 AP, 1/2 A, lowercase a, and P. So uppercase A is going to be area, the lowercase a is the apothem, and capital P is the perimeter. So they give us a lot of details here. In this one, 11 is going to be our apothem, and we have to find the perimeter by saying, okay, this is an octagon, that side's 9, and it's a regular, we're doing only regular shape. So it's a regular octagon, meaning that all of these sides are the same size. So that's 9, 9, 9, 9, all the way around. So we could add 9, 7, 8 times, or we could just multiply 9 times 8 and get 72. Okay, because it's an octagon, we multiply 8 times. That just gives us the perimeter. Then we come back over here to our formula. We say 1/2 or 0.5, because that's the same thing as 1/2. 1/2 times 11, because that's our apothem. Okay, that's our A, lowercase a. And then times 72, because that's our perimeter. We just multiply that, and we get our answer, 396. So 396, if you were going to say area, 396, and you could put, inches squared if you wanted to, because, technically that would be correct if you're talking about area. Now we're going to do more of that over here, so it gets a little bit trickier. There's more involved. They show us a lot of that information here at the top, where first we have to, kind of find our central angle or our apothem. This is the big deal. If we need to find the apothem, we need to determine what the central angle is first. So we find the measure of the central angle. In this case, we're looking at this shape right here, which is a pentagon. Okay, we know the central angle is going to be that divided by 5. That's why it's 360 divided by 5. So if it were a hexagon with 6 sides, it would be 360 divided by 6. If it were, an octagon, it'd be 360 divided by 8 if we were trying to find that central angle. Okay, so whatever it is, the number of sides, that's what we divide it by to find our central angle. In this case, it's going to be 72. So 72, and then we find that our AP, okay, this angle right here, angle rep, is it's going to be half of that, because again, that's a perpendicular bisector right here. That's what this 90-degree angle thing right here, that tells us it's bisecting both this line and this angle right here. It's bisecting this whole angle, so that this angle 1 would be equal to angle 2, and this side 1 would be equal to side 2. So that's what's happening right there. And that's why if the whole thing is 72, the half of it is 36. Then if we know that the perimeter is 60 centimeters, so it tells us right there, 60, we can do RS is 12, because we know, again, if we divided 60 divided by 5, because 5 sides, right? If all of these are 60, so if we did 1, 2, 3, 4, 5 sides, if all of them added together equals 60, then, and they're exactly equal, we just divide 60 by 5 to get 12. So that's how we found that RS was 12. And we know that our P, so just half of that distance right here, is half of that. So our P is 6. So now we've gone all that way just to get to, now we've got to find out what the actual apothem is. So we come back to this and we say, alright, so in this, we would know this is 6, and this angle, RAP, is 36. So we kind of have a triangle if we wanted to draw it up here. You know what, I'll draw it the way that, yeah, that's the way they did it. So we've got 6 down here, and up here we've got 36. Okay? And if we're trying to solve for this measure right here, well, across from angle 36, our given angle, that would be our opposite, and this would be adjacent, and the trig function that uses opposite over adjacent would be tangent. So the tangent of 36 is opposite over adjacent. So the opposite is 6, and the adjacent is AP, or in our case, I'm just going to put X. So, you guys might remember, whenever we did trigonometry, we do this kind of little switcheroo. Whenever X is on the bottom, we switch places. So what we're trying to find here, our X, is going to be divided on the left, and then we're going to have our opposite over tangent 36. When we do that in our calculator on degree mode, remember degree mode, we get 8.26. So we find that the area is 1/2 60, so the perimeter, and 1/2 60, which is the perimeter, times our apothem. So perimeter, and that's our lowercase a apothem, to get our answer of 247.8. I've done another one down here, a triangle, because it's a little bit different. We know that a triangle has 180 degrees in it. 180. So we know that if it's a regular triangle, that means it's an equilateral. So all three of these angles are 60, 60, 60. And that would mean that this angle right here it's half of that. So 30, because the central angle would be 60 as well. Therefore, the other part is 30.
I have you guys down, but I want to make sure I have the correct dish for you guys on Friday. Which one did you guys want? Shrimp Alfredo or chicken parmesan?
One of each.
One of each?
Mm-hmm.
Thank you.
Sorry about that. Let's get back to it. And here we go. So if that's 30, we can then determine a few other things. Since this right here is 14, since that's 14, we can say, oh man, this is bisected at a 90-degree angle. We remember this little right angle thing, that's 90 degrees. So that means it's bisected. That means that this is half of 14, or 7. So if we do that, we know this is 7. That's 30. And we can do a little bit of trigonometry. So again, we've got our triangle right here. We've got 7. We've got this given angle right here is 30. And then we can solve for x. And that's what we proceed to do right here. Tangent of 30 is opposite over adjacent, which means it's 7 over x. And we end up with x equals 7 over tan of 30. When we put that into our calculator, we get 12.1. 12.1. So Now that we have the apothem of 12.1, we come over here and we multiply 0.5 times 12.1, that's our apothem, times 42, because the perimeter is 14 plus 14 plus 14, and that equals 42. That's how we got this one right here. Our final answer, if you followed along properly, should be 254.1. Now, I want you to try to do the same thing. We've got another pentagon. It's almost exactly the same as this up here. Go ahead and try and do that one there. And then this one down here, it's a pentagon, but they give you everything. They give you everything that you need. So I'm going to give you two kind of similar ones to the one that we described up here. If you need some help, go ahead and let me know. But you can do this one all on your... Over here, we've got some composite shapes. These ones together, they include a lot of information, but we're basically going to be doing adding in, so we'll calculate the area of our rectangle, you know, something like that, and then calculate half of the area of a circle that has the radius, which is half of 15, 7.5, and then everything else included. So you can look at some of these instructions, and kind of the same thing here. We're just going to do the radius, or I'm sorry, the area of a square, and then the area of a triangle, and add it together. After that, you've got the last page here, and I want you to do 1, 3, 5, and 8. You should be able to work on those as easily as we did the rest of this. Okay. If you have any questions, feel free to let me know.